Hi, here we have another question from Iran Mathematical Olympiad round number 1, year 1998. This is a number theory question, and we have Fn is defined as the sum of the digit of n. For example, F1376 is equal to 1 plus 3, which is 4, plus 7, 11, plus 6, 17. Assume that n0 is equal to 13 power 76. Which single-digit number appears in the sequence n0, fn0, ffn0, and so on? First round of Iranian Mathematical Olympiad is usually consists of multiple choice questions. You get 3 hours, 30 questions, 6 minutes per question. This question was among the moderate difficulty questions. You can spend 5 to 10 minutes, try to solve this exercise, and then come back and see the solution. These are the options 1, 2, 3, 4, and none of them. All right, let's look at the solution. Here I have a theorem. If fn is the sum of the digit of a number n in base 10, we know that n modulus 9 is equal to fn. Let's prove this first. So assume that n is a number and we write it in this format. If that is n, then we can say that n is equal a0 times 10 power 0. This is the first digit. Second digit will be a1 times 10. Third digit will be a1 times 10 power 2, and so on. If we calculate this number modulo 9, 10 modulo 9 is 1. So actually all of these 10 power whatever modulo 9 become 1. Therefore, what we have is that number n modulo 9 becomes a0 plus a1 plus a2 and so on. And we know that this is the definition of fn. Therefore, n modulo 9 become equal to fn. Same way we can take fn and we can calculate it modulo 9. That becomes equal to f of fn. And so on. We can continue that way. Therefore, we know that in this sequence, the eventual number that is one digit number, because every time that we calculate fn, the value of fn becomes lesser than n. But eventually the number becomes a single digit and f of n in that case stays the same. So if we calculate this sequence, eventually we get to a single digit, and we know that this n modulo 9 will be equal to that single digit. So if we calculate n modulo 9, whatever single digit number that we get, that will be in this sequence. All right. Now, we have the n0 is 13 power 76. We know the 13 modulo 9 is 4, because 4 plus 9 is 13. So 13 modulo 9 becomes 4, so 4 power 76. We also know that 4 power 3 is 64. 64 modulo 9 is 1, because 63 is modulo 9 0, so it becomes 1. So I'm going to write 76 as a multiplication of 3, basically. So we can write 76 is 3 times 25, which will be 75 plus 1. But 4 power 3 modulo 9 is 1. So 4 power 3 times 25 modulo 9 is 1. And then we have another 4, so it becomes 4. Therefore, the single digit that we have in this sequence will be equal to 4. So the correct answer will be option D. Let's look at the technique that we have learned. If fn is the sum of the digit of n in the base of 10, then we know that n modulo 9 is equal to fn. Also, another important thing is to be able to calculate and reduce a number modulo another number. All right, so that's the end of this video. I hope you will learn something new. See you next time. Bye.